this is Ms. DB. In this video we are going to order and compare rational numbers, and we're also going to simplify absolute value expressions. So here I have a number line. This is kind of a zoomed in number line between 0 and 1, and you can see I have the tenths marked on here, and I have their decimal equivalents marked by each one of those tenths, and then there's just a few other common fractions and what their decimal equivalent would be. We could add other ones, like 1/3 would be right about here. That would be 1/3, and 1/3's decimal is 0.3 repeating, so 0.33333, and then 2/3 is about right here, and its decimal equivalent is 0.6 repeating, or 0.6666666. So we are going to, remember, rational numbers can all be written as fractions, but we could also write them all as decimals, so whichever one you prefer, really. You are going to look at these numbers. Some of them are decimals, some of them are fractions, and you're going to decide whether a greater than sign, a less than sign, or an equal sign goes into the blank. You can find these symbols on your keyboard. The less than and greater than and equal sign should all be readily available for you to type in, and make sure you remember which one's which. This reads greater than. So you would use this if the first number is greater than your second number. This is less than, so you would use this symbol if your first number is less than the second number. And of course you know what equal is. So let's look at number 2. It says 3/4, and then we have to decide if 3/4 is less than or greater than 0.8, or equal possibly. So one way you can do this is to find 3/4 on the number line up above. So 3/4 is one of these special numbers, and it's about right here, and 0.8 is right here. So again, you have to look at the first number and decide if the first number is less than or greater than the second number. And because 3/4 is to the left of 0.8, then I would say it is less than 0.8. The other way to do these, especially if you don't see those numbers on this number line up here, is to change them both to either fractions or decimals. For example, well, these are all up there. So all the ones that are up there as a fraction are on this bar. But let's say I had something in fifths. If I was going to compare 3/5 and 0.3, I don't know. This one, I don't know exactly where 3/5 is up there. Well, I do, but you might not know exactly where 3/5 is. So you could change it to a decimal number using your calculator. In the last assignment, we looked at how to change fractions to decimals, and you just take the top number divided by the bottom number. So it's 0.6. So 0.6 and 0.3. Now we can compare easily because I can see that 0.6 is greater than 0.3. So you can change them both to fractions or to decimals, or you can use this line up here. Some of them, like 4, 5, and 6, are not going to be on that number line up there, but they're already all written as either decimals or integer numbers, so you should be able to figure out whether the first number is less than the second number or greater than the second number. Alright, the next section we are going to order rational numbers. So we have several numbers here, and we need to write them in order from, oh, it says greatest to least. I thought it was least to greatest. So in this one, it's greatest to least. So make sure you always read the way they want you to write these. So one way to do this is to put them on the number line and then start reading, in this case, from the right to the left to read them from greatest to least. The other way would be to change them all to either decimals or fractions, and then you can compare them easier. Let's look at number 8. I'm going to put these on the number line, and then I will write them in order from greatest to least. So 1/3. 1/3 is, let's write these, let's fill this in a little bit. 1/3 was on, that was one of the ones that I added to this number line. And I can see that 1/3 is between 0.3 and 0.4, and it's equal to 0.333. So I'm going to put that on the number line right here. And I'm going to label it so I can remember what it is. Then 0.3 is next. That's very close to it, but a little bit less than it, isn't it? And then 0.1 is right here. And then 3/4. 3/4 was another one that was on that number line from before, so you can look back, but it's the same as 0.75, so that's about right here. Now it says to put these in order from greatest to least, so the greatest one is farthest to the right, and that's 3/4. And then I would go back. Next one is 1/3, then keep going, 0.3, then keep going, 0.1. So I've listed those in order from greatest to least. All right, here's some more ordering. One method is to do what we just did, put them on a number line and then order. This time it's from least to greatest, which I think is more common. The other way is to rewrite them all as decimals and then order. So you can decide if you want to put them on a number line, or if you can use one of your number lines you already have and find these, then you can write them in order from least to greatest. If you don't have a number line that has twelfths and elevenths and tenths on it, then the second method might be easier, and that is to change each of these numbers to a decimal and then order them. Let's do that for number 10. 11 divided by 12 is 0.916, and the 6 repeats. So I'm just going to write out a few 6's and then put dot dot dot. Now let's do 12 over 11. 1.09090909. 1.090909, and the 09's would repeat. The other way to write these even better, especially if you're writing with a pen rather than typing, is to put a bar over the 6, because the 6 was the one that kept going on. And in this one, it was the 0 and the 9 that kept going, so both of those would get the bar over them. 13/10, that one I could do without the calculator, but since we have it handy, let's just double check it. It should be 1.3, yes. So 1.3. So we're supposed to write these in order from least to greatest. The least one up here is the one I did first, because this one is less than 1. It's 0.916 repeating. That's the least one. So I'm going to write 11/12 is my least one. My second least one, so now we're comparing these two. They're both 1 point, so then we have to look at the number that's in the tenths place. And 0 is less than 3, so the next one is 1.09, which was the 12 over 11ths. And then finally the 1.3 is the largest, that was the 13/10. So you should put them back into their original form in order to write them in order from least to greatest. Okay, so next we will look at absolute value. What is absolute value? Absolute value of a number is its distance from 0 on the number line. And next part is very important. When we talk about distance, it's always positive. My town is Little Falls, and I live about 30 miles from Brainerd. When I get to Brainerd, I have to turn around and come home after I'm done doing whatever I need to do. So I drive 30 miles from Brainerd to Little Falls. I don't say that I drive negative 30 miles to get to Little Falls. We always just say 30 miles. It's always positive. That means that the absolute value of a number is always positive. The absolute value of a positive number is positive. The absolute value of a negative number is positive. It's always positive, no matter what kind of number you started with. So opposite integers have the same absolute value. We put bars around a number to show that we have absolute value. You can find those bars on a keyboard. They are on my keyboard. It is right above the Enter key, and I have to hit Shift to get to it. So it looks like that. And then you type your number and then you put the other one. That means the absolute value of 4, which would be 4, by the way, because it's always positive. So all you have to do for 12 and 13 is say what the absolute value of that number would be, and your answer better be a positive number. On 14, because the 16 minus 98 is inside the absolute value signs, that's a type of grouping. So it's just like if it had been in parentheses. So you don't take the absolute value of 16 and the absolute value of 98. You simplify what 16 minus 98 is. It's negative 82. And then you take the absolute value. So the absolute value of negative 82 is 82. In something like, let's do 15 as well. In 15, 11 minus, and then you take the absolute value of negative 4. The absolute value of negative 4 is 4, so your problem has become 11 minus 4, which you can finish that one. How about something like 19? 19 says take the opposite, the negative, of whatever you get when you take the absolute value of negative 7. Well, the absolute value of negative 7 is just 7. So this problem is saying what is the negative of 7, and that's just negative 7. So work on these. Make sure you remember that after you take the absolute value of a number, it'll always be positive, but you don't automatically take the positive of every number. Like in 17, you do the work, and then you'll have the absolute value of whatever negative 5 minus 11 is. All right, let me know if you have any questions, and have a wonderful